Hello, in this video tutorial we're going to look at Lab 1 for Advanced GIS at UVU in spring 2023. In this tutorial we're going to look at georeferencing, imagery for kind of an overlay analysis with our own GIS analyses, and also I'll give you some advice about using our overall drive for saving files and how to manage your data in this class. Okay, so I've connected to our GIS groups drive here at UVU, and I noticed that most everybody has made their own folder already. Note that I'm storing data for labs 1, 2, and so on in here, and that you can also download ArcGIS Pro from this folder, although you'll need a separate license file if you want to use that. So in here we can find lab 1, and this lab is all about interpolating rainfall data, and we've worked on that quite a bit. I'm not going to get into the details of those interpolations here. This is about georeferencing and about utilizing those drive spaces. So I asked you to georeference this file here. So let's go ahead and open that. And so here we have interpolated from this PRISM climate group at Oregon State University, average annual precipitation for Utah 1991 to 2020. Let's download a high resolution image of that. So I'll right click on the DPI 300, and right click is not going to work, so I'll regular click. Okay, it's put it in my downloads, so let's go to that folder and we'll cut it. And I'm going to ask you to generally in your lab work on My Documents in your folder. And so here I'm going to put lab 1 GEOG 3650 folder, and I'll paste it in there. The reason that we want to work locally on your machines in the lab is that if we work over the network with this GIS groups drive, oftentimes when you're processing some GIS analyses that take, say, 10-15 minutes, you might get one small error in the network, and that will fail the processing. And you'll have to redo it, and who knows, maybe you'll fail again, and then you've wasted 30 minutes of your time. So better to process things locally as you're working throughout the day. At the end of the day, we do want to use that GIS groups folder to back things up, and so then you can go and copy the whole folder and what you've done and move it to your folder in GIS groups. Okay. So I've got that saved in my documents. Now let's go and open up a new blank map. I'm going to go ahead and save my lab 1 where I was just talking about. So I'll go to My Documents again, and it should be in there, and that's where my project is going to go, and I'm going to call it Lab 1, and this one is georeferencing that we're focusing on. Okay. So we're using ArcGIS Pro. Could do this in ArcMap or in QGIS as well, but generally we're going to use mostly ArcGIS Pro in this class, so let's do it here. Okay, so symbology, we have nothing open. So I'm going to go to the catalog pane here. Let's try to dock this and go to my folder. Here's my lab 1, but we want to add a new folder connection just outside of that because I'm not seeing the other thing. So I'll go back to my documents just to make sure. Oh, Yeah, it's there, but it's outside of that folder. So we want to add that, so we can drag it in here. It should open up that way. Probably generally a good idea for any image to always build pyramids and calculate the statistics. Will make things run faster in future analyses. So when you add an unreferenced image, you won't see it initially because it doesn't have any world file. It doesn't know where it is. It's just an image. But that's what we're going to do, is give it positioned where it is. So let's right click or just down drop click and dock this as well. Make it neater. So to do georeferencing, given that we have these base maps, it's not so hard. We don't need other image to reference to because we already have the edges of Utah here. And this is just going to be for visualization, no real quantitative analyses. So this will be good enough. So now if I go to click imagery on the upper menu file here, since that's what we're dealing with, and click georeference, now we'll be ready to georeference that image. These tabs kind of hide on you sometimes, so if they hide, just got to go back up there and click. So I'm going to right click and zoom to that layer, so it'll take me to wherever it is in the space of the map. And it's not really anywhere because it doesn't have position. But so the first thing we need to do is give it some positions. And so this is referred to as adding control points. So within this georeferencing pane, you can always click fit to display, which will kind of put it to the maximum of your display. So I just did that. You could do other things, like you could flip it upside down if it's not showing up right, move it around. All these sorts of adjustments are here. But we're going to do georeferencing through adding control points and kind of like basically pick a point on the image we're trying to reference and tell it where that is in space, and it's going to slide it over there. And then as we add more points, it'll get a sense of scale and be close to reality. As we add control points, this control point table that I'm going to click on here will become populated. And so I'll show you that in a minute. For now, I'll close that. So let's go back to GeoReference. Let's click Add Control Points. If I bring my cursor down, we should now, if I click, then I get my point here. I can click anywhere. It'll kind of say, okay, I'm going to grab that point and I'm going to show it where it is in real space. So I'll click this edge here. And then it's like, okay, wait, but then where do I want to go back to? So let's go zoom to the layer of the world topographic map. Oh, we were somewhere near the equator. Let's zoom into Utah. I think I picked this upper right corner of the top of Utah. And so now you can see our map has rubber sheeted right over to here. And there it is. Okay. But it's too small, so we have to fix that. So let's pick another control point so I can zoom into it. Remember, we always have to click first on the map itself that you're trying to move. Then I can go, in this case, zooming back out will be better because I don't, it would be better if I had something from the state of Utah open so that I could just say zoom to that layer and it would be a little faster. But it won't matter much here in a second. As I click this second point, things should start to look pretty okay. Right? So now Utah should start to look like it's where Utah should be. So it's important to note that as we're doing our georeferencing, we're georeferencing within whatever coordinate system that we've got here. And so here we see that it's in a geographic coordinate system, degrees, right? And that may or may not match up with how this initial projection of the map that we're using is working out, and that'll impact how well we fit this. But it's, again, going to be okay for this particular application since we're just trying to see how our interpolations worked relative to the prism detailed resolutions of Oregon State's research group there. So click this other corner, and then I'm going to have to turn off the map. Oh, it's looking pretty good. Okay, but if I zoom in, we can see I can make some improvements. Okay, now I can turn the map back on. So I'm going to do each of these corners. And up here you can see on the upper right, you can see there's this little georeferencing information. It tells us some things. So we have so far added 3 control points. It tells us the total root mean squared errors, which is 0 because the type of transformation we're using is first order polynomial, which is basically we're just kind of stretching it to fit. And we've only got 3 points, so it will always fit perfectly for whatever we told it to be. It's got no model error. It doesn't mean that it doesn't have error. We can see that if we turn the image off, the other corner that I'm going to do next over here in the upper left is not where it's supposed to be. There is indeed error in our georeferencing. It's just that the control points are exactly where we told them to be using the first order polynomial model. And so you need to balance, as we add more control points, we'll add a 4th, we'll see that this will start to have some root mean squared error. And that's because the model can't be fit perfectly anymore. And so as that happens, we want to optimize how well we've positioned our coordinate systems across the space of the image, the control points, to make that projection image that we're adding on match reality as best we can. Okay, so let's get a good spot here, and you can see some reasons for the error, right? Like there's pixelation of this image that we're referencing. Maybe I didn't click perfectly to begin with. So we want to be down here. And now immediately you can see we've moved it from, we told it we want it to be here, but it's actually only here. We can now see we have some root mean squared error, and the units are, it's not clear to me what units those are, but we can see after the fact. One thing is, I know that the first control point I picked, I didn't zoom in very well to it. Like, yeah, so I could probably redo that one. And so that's a good way to kind of improve your root mean squared error. So if I pull up the control point table, we probably will see that the first one has a fairly high residual, but actually it's not so bad. But I know that I didn't pick it as well. So I'm going to highlight it, and you can either press delete or you can hit right here this little delete selected. That one should go away. And I can redo it. So I can go back to georeferencing, click add control points, and then I click that corner. Didn't get it. Let me try again. Okay. Now I turn off my map, and yeah, it should be up there. And maybe I did a little bit better, although I didn't do very well, so I should have should edit that if I can. No, that last one I didn't click well again, so let me try again. Press delete, turn it back on. Get this corner. Takes a couple clicks to get it back working. Now let's zoom back to this corner and do a little bit better job. Okay. Okay, so it's still not perfect. The root mean square error that we're getting, these residuals, are 1,708.9 of some units. Not sure. Maybe it's in meters, it seems, because degrees would not make sense. So let's try to do the bottom of the state, see if we can improve this a little bit, or see if it's good enough. Again, turn off Okay, that seems like it made a nice adjustment. Looks happy. I like to scroll out, go over here to this other corner. Click, turn it off. Find the four corners. Turn it back on. See how we've done. It's not perfect. We can see actually our residuals have gone up as we've added more points. Clearly the projection of that initial image that we're georeferencing was not matching our coordinate system on this map here. That's okay. Again, for this case, we're just trying to visualize the pattern of precipitation on a statewide basis. So I think that's going to be good enough. If we wanted to, at this point, we have 1, 2, 3, 4, 5, 6. We could move to a second order polynomial, which will actually give us 0 in terms of residuals. But the question is if it gives us a better model for the state here. So let's look at what we got. I'm going to switch to second order polynomial, watch what happens within the control point table, look at the residuals. Right now we've got between 1 and 10,000 for residual. As I click second order polynomial, we'll see those change to 0, and we should see the shape of the map change too. Okay, so you can see the map change to a more kind of rectangular shape, and all the residuals went to 0. Now we have a second order polynomial fit, and it's looking a lot better in terms of like just how it's dealing with things. And if we really wanted to, we could go into the Great Salt Lake if we trust that position, and we can see that it's not bad off. Antelope Island looks like where it should be. This is really good enough. Okay. So once you're done with your georeferencing and you like it, there's two things you can do. You can choose to save, which basically will give a world file, a position in space, to the image that you brought in. And then that's a good idea. However, save to new might be a better idea, because basically you've permanently changed the file you have. Is that's the only file that you had and you didn't really want it to be a GIS file only, then it might be better to save it to a new file that is a GIS file. So I'm going to do that. And so I'm going to go ahead and make sure that's in the folder that I want it to be in. It's in my Lab 1 georeferencing. I could also put it inside of the geodatabase for this project. But for now, I'm going to leave it here. I'm going to call it Prism Utah. That 300 stands for DPI. And then I'm going to say underscore georef. And I'll leave it as .tiff. And I'm just going to use the default coordinate system, which we've been doing the georeferencing in. And it's 8-bit unsigned, so that means it's 0 to 255, and it's got 3 bands of color. I think that's already preserved in here, probably. I'm not sure where that's said, but so the 8 bits unsigned is correct. If we were going to do this with something else, like a digital elevation model, we'd need to change that, but this is correct for values of 0 to 255 color. So I'll export. Oh, it failed to export the data. Why is that? Let's change it to the back to my documents. I'm going to put it in that lab, and in Lab 1 in the geodatabase, and I'm going to call it Utah 300 georef.tiff. I'm not sure why it failed, so hopefully this works. Export. says exporting, although up here it still says failed to export, but that's probably the prior issue. Okay, so it disappeared as I saved to new. No, it didn't disappear. I turned it off. Sorry. Okay, so it's still trying to export, and that is seeming rather problematic. So I'm going to go ahead and view whether or not these new files were created. Going into my documents, to the lab. I can see that in the lab 1 file, we've got the PNG file. Maybe I should have kept it as a PNG. Also, I can see that there have been pyramids created, which is what I told it to do. Within the geodatabase, I'm not going to be able to look at this very easily, I don't think. No, because it's all zipped in a way we can't see it. So to look at that, we would go back to catalog pane and go into the geodatabase where I was just trying to save it. And yeah, it is showing up there now as Utah 300 GeoRef. So perhaps it's finished. Let's add it to the map. Ooh, maybe it wasn't finished. So I'm not seeing it yet. Let's remove that. Go back. Still says it's exporting. If you want to look at what's going on, usually I think you can go to analysis and go to the history for up here of geoprocessing. Not showing up. Okay, I'm going to stop this. It says failed to export. I'm going to do what I said not to do. So I'm going to go back to Georeference. I'm going to click Save. Okay. And so I think if we go back to Lab 1, now if we refresh it, actually we didn't have to refresh it, we see now 4 files here. We see the PNG and also the PGWX file for Utah 300. Before there were 3. The WX is the world geographic file, so it can tell that image, the PNG image, where it is in a GIS space. So that should have worked. Again, we've overwritten that initial file, so if you don't want that to occur through the save function in georeferencing, maybe you copy it, move it to your GIS folder first, and then save. I'm not sure why the save and export was not running quickly. So I'm going to close that. If I close my georeferencing, it's now there still where it is. So that did work. We could now export it by going under, right-clicking on the file itself. We could export that new raster any way we wanted at this point, which isn't all that different than what I was just trying to do. So hopefully this helps you with georeferencing, realizing that you may also get into some errors. There are some ways to troubleshoot through those errors. In terms of saving, remember to always save to a folder in your documents and try to keep everything in one folder for each lab so it'll be easy for you to back up. In this case, I made a folder in my documents, lab 1, GEOG 3650, and I put that georeference file here, and then also this folder here has to do with our PRJX file, our project file, APRX file for ArcPro. Inside of that, we can see the geodatabase, and that's a perfectly good place to save your data to as well. Generally, it's a great idea to save to your geodatabase for a variety of reasons to do with coordinate systems and other things. It's also very transferable. But the downside of it, in one sense is an upside, another sense is a downside. If I go into that folder, it's all gibbledygook. Even though I could have 15 rasters and other things in there, you can't really navigate it in a Windows setting. So it's going to be hard for you to utilize in another program. Say you wanted to take that elsewhere. But it is well saved within there, and so it kind of prevents the user from making silly mistakes like removing one file, which would make the file not work, like if we lost part of this file. Anyways, yeah, so then to back up what I did, I just say copy, and I would go to my GIS groups folder, go to Tokay files. At the end of the day, when I'm done, I'll go ahead and paste and save it in here. Okay, so hopefully that's a good introduction to georeferencing and how I want you to manage files for this class.